morning. So here it's very early, but I'm speaking to someone who is on the other side of this beautiful earth. So I'm speaking to John. And John, maybe you can tell me where are you? Where are you situated at the moment?
Yeah. Good afternoon, Italia. I feel like being Australian, I have to put on an Australian accent or something. So, but yeah, g'day. I'm John from Australia, over in Perth, which is on the west coast, which is where I think a lot of people think of Australia. They think of Sydney and Melbourne and a lot of the beautiful cities you have over there. But then if you catch a 5 hour flight, you can stay in Australia and land in the sunny town of Perth, which is where I'm based at the moment.
Mm. And yeah, I saw your work on, I think it was Twitter first, and then later
Mm.
on that I saw that you're on LinkedIn active as well. So yeah, what are you doing? So why did I contact you? Why am I interested in you and your work?
Oh, wow. Well, I feel like you should answer that question, but I can just say why you might be interested. Um,
Yes.
yeah, so I've been posting on LinkedIn and Twitter or X for probably a couple of years now. Um, I started out just as a way I was working in AI for a mining company, a mineral extraction company in Perth, and I was thinking I wanted to. I'd been doing a bunch of robotic stuff for them, but I'd moved into AI and I was like, oh, I want to make sure I keep my robotic skills alive. So I started a little project on the side, delivering coffee at a cool coffee shop in Perth City. And so I started posting about that, and that was quite fun. And I started writing and learning how to write and communicate a bit better. And so, that's I guess so I just started putting out stuff, getting feedback, hearing about what people thought was interesting, and learning to communicate. So I think it's important as an engineer, and hopefully a leader in some capacity, to be able to like get your ideas out there and have people understand you and what you're about. So perhaps you found me in one of my posts where I often one thing that I think is, it used to be underrated. I think that everybody's kind of caught on to it now, but for a little while there was a bit of, I guess, elitism around using Linux versus Windows, and in particular, I found that in my career as I've started out robotics and Linux and stuff. But a great way to get beginners into robotics, I think, is to give them access to WSL, Windows subsystem for Linux. Lets them use a lot of our modern, amazing open source ROS tools without having to commit to um, you know, like dual booting and understanding all of the stuff you have to understand when it comes to a Linux command line. So yeah, that's possibly where you may have first seen, because it seems whenever I talk about that, everybody like gets very excited. So yeah.
I mean, it's always good to have people that are excited about their work, and yeah. But so this is some things that you're working on at the moment, and yeah, what you're posting about. But yeah, maybe you can go back a few steps, and you can tell me about your background and how you came across robotics, and yeah,
Yeah.
I would be very interested in that.
All right. So I've been in this been in this field for a long time. I graduated from Wollongong University, so on the other side of Australia, with an electrical engineering bachelor's, and I didn't really know what to do, but you apply for some jobs, and I got three job offers, and one of them sounded very interesting. It was at a nuclear research facility. So Australia doesn't have any nuclear, like much nuclear at all, but we've got this one little research facility that makes like silicon chips and makes medical isotopes and stuff. And so I got a job there because it sounded really cool, and I was fresh out of university, and I joined their grad program. And this is great. I made it into a grad program. Doing engineering in a nuclear science. How cool is that? And it was cool. And Ansto is the group I joined. Really really great work that they do. But I discovered after about a year of doing that job that just being an engineer is really boring. Like especially when you're a graduate engineer, you have to do a lot of stuff which I just didn't find very interesting. So the day that it dawned upon me that I probably needed to find a different career was I was I was doing something I thought was really cool, right? Like in principle, it's really cool. So there are two reactors at Lucas Heights, which is this place, and one of them's been shut down, and I was part of a team that was helping to decommission it. And that sounds really cool. And so I, could go inside of this nuclear reactor, and it was like a submarine. It had these big doors that would open, and you had to have this airlock pressure, and you walk in, you felt like you were in some like 1950s Bond villain
Sounds like a
movie.
movie. Yeah,
Yeah,
sounds like a game.
it was incredible. It was like Half-Life, like Half-Life 1, if you guys, if you remember that, right? Like, it was incredible, like incredible setting. But my job was so boring. I had a light meter, and it was my job to walk around all the different platforms and measure how much light was there so that we could install sufficient light so that if anybody ever happened to want to go in there, there'd be enough light and they wouldn't trip over something. And like, that's an important job. But oh my God, actually doing that job was terrible. Like, it was just really boring. And I was like, oh man, there's got to be something kind of, more interesting. So I started looking around for other jobs and things. And I was fortunate enough that I'd gotten good enough grades in my undergrad. In Australia, if you get like first class honors in your undergrad, you're able to get a scholarship to do a PhD at a university in Australia. So I had that going for me. And so I started looking around thinking maybe I'll get into research. And maybe robotics is pretty cool. And so I started reading robotics papers, and I read this one robotics paper about a thing called SLAM, which I'm sure you all know if you're robotics people. And it was the SLAM tutorial by Hugh Durrant-White and Tim Bailey. And I was like, this is a really cool idea. Like, I love the idea that robots can, how they would represent their understanding of the world, right? So if you don't know, SLAM stands for simultaneous localization and mapping, and it's the technique that robots use to understand where they are in a map that they might have of the world. So, if you remember when we used to have not Google Maps, but like paper maps, and you would look at a map and then you'd look around and you would try and figure out where you were on that map. That's kind of what SLAM did. You'd give the robot a map and you'd give it some vision, and it would try and figure out where it was on that map. While at the same time actually drawing more of the map, because that's why it's localization and mapping. But anyway, so they wrote this paper about this. I thought it was really cool, and I thought, these people seem really smart and interesting. I wonder where they are. And it turned out they were in Sydney at a place called the Australian Centre for Field Robotics, and the reactor that I was working at was also in the outskirts of Sydney. So I thought, all right, well, maybe I'll send them an email, I guess, that you could do that. And so I sent them an email saying,
So which year,
hey,
which year are we talking about?
oh yeah, how long ago is this? Oh God. I need to bring up my LinkedIn so I remember my career history. I think this would have been 2008 or 2009.
All right.
So yeah,
That's all right.
long time ago, I think. I think it was about 2008, 2009. Anyway, and Hugh and Tim Bailey were, nice enough to respond to my email, and young nuclear engineer wanting to do robotics, and and said, yeah, why don't you come and do a PhD with us? And so, oh, that's really great. So went and did a PhD at Australian Centre for Field Robotics, which was really amazing. I got to meet a whole lot of other people. I think I was really fortunate with that program, because I think for some people PhDs can be quite lonely experiences. They can be, you're just one or two people working on this obscure thing. But at ACFR, at least at the time that I was there, it was like it wasn't like a massive party, but there was like 20 PhD students all studying different aspects of robotics all at the same time, all graduating. And so it created this kind of buzz, this sort of this really cool vibe. We would have people coming in, different researchers would come in weekly and present some of their work as they were visiting, and either that or the PhD students who were graduating or were publishing would be talking about the papers that they'd written, or their their thesis that they'd written. And that was really amazing way to get into robotics. It was really, really cool. Yeah, so I guess that's how it started.
I mean, I'm always very jealous. Maybe might not be the entire right word, but it goes into the right direction. So as I went to university very late in my life, so at 30. So I was among students that were 10 years younger than I was, And
Mm.
so, I mean, I've seen I've seen the student life, but I was in a totally different point in my life. So every
Yeah.
time I'm hearing this kind of story and the excitement that people are having, I'm very lucky for you that you were able to, as you said, experience this. And this was not a time only studying lonely with your books, but really enjoying the time. And I do know that, and I mean, everyone knows that Australia know how to have a good time. So, uh, but not
Yeah.
only partying, but I mean, being generally enjoying life. And I
Yeah.
have a few Australian friends, and always nice talking to them. And so it's interesting seeing this from academia point of view. And
Mm.
that even in that part of life, life can still be enjoyed. And so
Yeah.
when you said, okay, you started, you start working, and then you said, this is not mine. A lot of people have this moment, right? And then just
Mm.
doing something randomly, and then as sending an email that leads to something totally different, is always something
Yeah.
that should be inspire people. That you just, I mean, now it sounds like a very bad movie title, but you're just one email away from a different life. So
Yeah. Yeah. Yeah.
and what happened then? So you the PhD, how long is that kind of program? I think it's 5 years, or it depends, I guess.
Yeah, it depends. In Australia, you can usually, if you're good enough, you can graduate in 3. I wasn't good enough. I took a bit longer. It took me about 4 years to get my PhD.
Ooh.
Um, yeah, yeah, but it was okay. So after that, and by the way, I do want to say it wasn't like party town. We were a giant bunch of nerds, but it was more like
Enjoying
for me
working
as a giant
together.
nerd. Yeah, it was really fun. It was just fun to learn from people, and you learn about their projects and their different things, and learn about all the background that goes into robotics because it's such a broad, immense field. Um, yeah, actually, and I remember I will get on to what happened next, but it just reminds me one of my colleagues at the time at one of my other contemporary PhD students was doing this thing called deep learning, and at the time, I remember, learning about like, this is never going to catch on. And oh my God, you know, fast forward, oh my God, deep learning, how amazing. But anyway, yeah, so after that, I went to work for a research kind of pseudo government research organization called NICTA, that was National, anyway, ICT for like Information Computer Technology Australia. And during that time, I started looking at sort of I guess, much more of the AI side, and machine learning side of things. My research ended up being in simultaneous localization and mapping. It ended up being in distributed, decentralized ways of doing that, and ways of making sure that um, I guess your SLAM estimates are safe. But we don't have to go into what my PhD was about, but like at a high level, that's sort of, I guess, what it was about. And then, but yeah, so I moved into NICTA and started looking at sort of more machine learning, maths and statistics type problems. And this kind of involved, understanding geology and these sorts of kind of mineral extraction sorts of things, which is very stereotypical for Australians because kind of the biggest thing that we do in Australia is we dig up dirt or we extract gas from our huge landmass. So I feel like and that was not my first run in with that industry for sure. But anyway, so I sort of hung out there for a little bit, and then moved across with that business to Queensland, where I did similar kind of research, AI machine learning research in Queensland for NICTA, which then kind of got absorbed into a company called CSIRO, which is the big research body. But at that point in my career, I'd been doing a bit of machine learning. I'd become quite good at it. But I felt like it was time to try and do a startup. So I kind of took a big U-turn, I suppose, and went looking for other things. And also at
What do you
that
mean
time,
other
my
things?
my huh?
What do you mean other
Well,
things?
I went and tried my hand at all sorts of machine learning startups and stuff, and moved to Perth. My wife got a job she got a pretty cool job at a startup here, and then later on at an oil and gas company. I was looking at all things that aren't really robotics, to be honest. I was looking at an idea for how to use AI to edit videos and these sorts of things for a long time. But eventually I realized that I should probably come back to my roots and start seeing if I could bring AI and robotics together, because now I had a capability in kind of both. Um, and so being in Perth and being in Australia, I thought it was probably time to start looking at autonomous vehicles. And this is probably 2016, 2017 now. So, many years has passed and stuff. So this is right in the peak of when like self-driving cars is a thing and everybody was, and we had this, we were going around pitching to mining companies. What if we were to take some of the amazing work that was being done in the self-driving car space, because it's quite open, and apply it to mining trucks. And this is this is reasonably ambitious, because the mining companies, some of them at least, already had autonomous mining vehicles. The big players in that space are companies like Caterpillar and Komatsu, who make these huge dump trucks that move all this dirt around. And they'd already, actually, with some help from, the Rio Tinto guys got help from ACFR. They'd already automated some of these big dump trucks. But what we were proposing around town was that what if you could use some of the, now that a lot of the self-driving car tech had become open, at least some of the basic stuff, you could use that to make a much more cost-effective autonomous system. And so I was going around town trying to.
And with open, you mean open source?
Yeah, yeah. So like you could take ROS, you could take AutoWare. A lot of these frameworks were open, and they were able to make a light vehicle. A haul truck is just a really heavy, a light vehicle, I mean by a car. A haul truck is just a really big, heavy car that has a lot of safety issues. But in principle, it's like four wheels and they move and they have to brake and stop. And the existing systems that were out there, at least at the time, they were very, very basic. So to give you an idea about some of the Caterpillar systems, or actually not even Caterpillar, like all the systems at the time, right? They what they had is they would have like a Velodyne LiDAR at the front that was designed purely for collision avoidance or obstacle detection. So if there was anything, if it saw anything with that, it would stop. And then they would basically just use GPS waypoints to drive the trucks around. The trucks were just using kind of GPS nav. So like really, really super basic. And so we thought we could maybe do something a bit better. Ended up getting the attention of a big mining company in town that sort of, absorbed us into their company. And
Who's us?
So that was me and I was in a little company called Project 412 at that time. So me and a few friends, a few other guys who were really into mining at the time. And so we kind of went into this big company, and like big mega, one of the top 3 iron ore mining companies in Australia. And we got to work looking at how we can make automated vehicles in the mining context. So that was pretty cool. But I guess that it was really good, and I helped to start something really, really great there. But sometimes when you go into a big company, you just sort of, you get bounced around and you move around. And so what I found was that I wasn't really getting, I guess, what I needed out of being part of the autonomy team anymore. They'd gone and grown in I guess, different ways to what I was interested in. And so I found myself back in AI. So I stood up an AI team in this big company and started doing really cool AI stuff again. And so this is the story of my career. Seems to be I just keep bouncing between being a roboticist and being an AI guy. Actually, I think there's I think at the end of it, I suppose that I think there's some hope for the future in that regard. But so bouncing around, I went back to being AI in mining and looking at understanding how can they leverage a lot of their data, because mining companies collect a lot of data. How can they build systems, take advantage of like large language models as they were in their infancy, and then ChatGPT came out. And then I suppose maybe the other side of my story is I kind of get bored real easily, and so after about 4 years of that stuff, I was a bit sick of being just an AI guy in a mining company. And so I found a cool robotics startup in Perth, a cool robotics company in Perth called Nexus, that was building these robots that, among other things, have magnets for feet and like quadrupeds. Basically looks like a spider. And what I did was I came and joined them and started leading that project. So that was very, very cool. And I'm still involved with them at the moment. But what I'm really looking at right now is um, I think that I want to help people get better at doing robotics and doing ROS. And so I'm sort of working with that robot, like spider robot company at the moment. But I'm also looking at education and training and trying to make it really easy for beginners to start using ROS. And because I think that like if we want to start, like there's lots of problems that the world's going to face, like climate change and just generally like cost of living. We're going to need to start automating stuff. But if the best tools for automation are like locked up in this arcane thing called ROS that only people with PhDs could use, that's kind of not good for the planet. It's not good for humanity. So what I'm looking at is how can I make it easy for people to just start using these advanced tools, but without necessarily having to go through a long journey. And so, yeah, so I'm doing that. And I think my ultimate goal is to try and bring it all together. So I suppose my story arc, hopefully this is, so right now that's where I'm at. Hopefully my story arc is going to involve these two threads now at the point in time where they're ready to come together. So, robotics for a long time robots have been capable of doing stuff like the physically moving arms and picking up objects has been, not completely difficult to do, although they've been high cost. But the capability of doing perception, capability of doing general tasks that don't need lots of human effort to set up scenarios or don't need huge open spaces, like in the mining example where you can, just use GPS and not care too much because there's not much around. You know, robotics has been kind of limited by its ability to perceive the world, to act, and to do general tasks. But like we're seeing now, projects like Google made this, RT1 transformer that lets you treat moving robots like another language. And there's other examples like the OK robot, which came out recently, which was a robot where you just ask it, go into this room and pick up a bag of chips, and it'll work out how to do all the things that are needed to do that. And so what I'm hoping to do with my education is to start out by making ROS easy for people to do. And once I figure out how to make ROS easy, I want to make how to make ROS with AI easy to do, because there's already great examples of researchers, being able to build, sophisticated ROS robots that use AI. But, could we make an easy path where you go, okay, cool, I'm going to make a robot, build a robot, put an AI in that robot, and now that robot can, deal with the environment in a really dynamic way. And that's super hard, by the way. I'm not saying that that's going to be like, hey, yeah, it's ready tomorrow, but that's
This is the
ultimate goal
direction
where
you're
I'm
going
heading.
to.
Yeah. Yeah.
I mean, you were just mentioning that, so you were bouncing around. I mean, for me, it is bouncing around one line, and that line is what is interesting me. So if I'm doing this and this is not interesting for me anymore, why should I keep doing this, right? Only because I'm on that path. So I think it shows very clearly that you can do different kind of things, but in the very end, it must be something that is not useful for someone, but useful for yourself. I mean, and even if that is just, it is interesting enough for me to keep stay on that line. And you were mentioning, yeah, making ROS easier. So on LinkedIn, I have a lot of people that are students or PhD students or early in their career doing a bachelor's or master's and getting in contact. I mean, they can be mechanical engineers or electrical engineers, and then, robotics is interesting for me. And I mean, really, I have a lot of people asking, so how do you get really into ROS? And I mean, there is a lot of documentation out there. Obviously, I mean, this is the biggest community when it comes to open source robotics. But still, I mean, apparently you were just mentioning maybe it should be available for people that are not only necessarily doing a PhD, right? So
Yeah.
just the other day, I saw someone mentioning, so for the higher complex stuff, you do ROS, and before that, you start with Arduino. And
Yeah.
so I think the first time I saw you were when I saw that you were doing I think it was a 6 week program, and within 6 weeks you will be able to do and really be working and building on robots. So I think this is definitely an approach. I mean, the what I see very often is Lego, for example. The very so you can build some stuff and you can control it. So I think
Yeah.
this would be most likely one of the earliest stuff that kids can get in contact very easily with electronic parts. And I think there's even some programming involved at the moment, or recently. And but yeah, making it more accessible. This is always the you were
Yeah.
mentioning a few startups. Sorry,
Yeah.
yeah, you were mentioning a few startups, especially when you look in robotics. There's mobile robotics and then there's stationary robots.
Mm.
So these these robot companies, it's just a few, right? That are very
Yeah.
big and they have the biggest share of the market.
Mm.
They were just, I mean, I had the discussion last time with the with Tobias Ritzler, who is having this company here in Germany. That it was Universal Robots that made robots accessible for people. So you can buy, I mean, it's still kind of expensive for 25K for a
Yeah.
cobot, but I mean,
Yeah.
25K is not 150, right? So,
Mm.
and
Yeah.
be having this academy where you can actually learn how to control the robot and program it in a very easy way, and the tutorials yeah, it's very easy and accessible. So this
Mm.
democratization of robotics, I think, is very, very important to make it
Mm.
accessible for everyone. And yeah,
Yeah.
so maybe you can tell me a little bit more about what you're planning with this course.
Yeah, yeah, I'll definitely tell you about the course. Actually, I've got a few opinions about some of the other things you said though, which I might
Mm-hmm.
just dispense
Mm-hmm.
with. Um, so it's funny. I like when I was you know, like robotics is a really big field. Do you know what I mean? Like, there's so much that one could know because um, it's like an end product field, right? Like, perhaps an example. I don't know if it's going to make sense or not, but like, people like talk about web development. And web development, what do? You have to use JavaScript to make a website. Okay, cool. But in robotics, it's kind of like, yeah, but you also have to make the computer and the silicon chips and the power supply, and then you can have a website, right? Like, because you can't often just do it. But I think that we could take a leaf from the book of web development and go, yeah, but do you want to make the computer? Do you want to make the screen or the internet router or whatever it is, right? Like, so although like you could, if you're making your own robot and you wanted to do it completely from scratch, yes, you could use an Arduino, you use motor control, you could design electronic circuits. But you know, you'll find, and my advice to anybody out there who's thinking, I want to be a roboticist and I want to, start doing it, is like, I think you should, instead of trying to learn stuff, try to do stuff. Um, so instead of going, oh, I need to build a robot, so I'm going to learn how motors work, I'm going to learn how mechanics work, structural mechanics work, I'm going to learn how to program Arduinos, going to learn about, power circuits and, power supplies and how to drive my motors properly, and all of this hard stuff actually that is not easy actually to do, right? People can spend whole lives going into the depths of electrical design and mechanical design. Instead, like, just buy something that someone's already made. There are, like, you can buy the UR arm. I mean, that one's is pretty expensive, but there are plenty of I guess there's cheaper options out there. But
Yeah.
instead of even buying it, like, the real question, I think the more interesting thing is, what would you like a robot to solve, and then work from that to go, what does the robot need to do? Then what does the robot need to look like? And then and then is there a robot that's close enough that I could buy and then work on? Because I guess if you take that approach, then you can kind of go, and that's why I think Ross is such a powerful tool, right? You can go, okay, cool. I'm going to look, okay, I'm trying to solve problem X. I'm going to use Ross because Ross is probably the best thing to use in terms of it's most open and it's most accessible. It's got the most community, whatever. Um, and then I'm going to find robots that kind of hopefully fit what I need to do and are integratable with Ross in some way. And then I'll try and integrate a solution together. And even though you won't learn the full stack of robotics. At least you'll learn the most important pieces. And what you'll probably learn is the things like, I guess, if we want to teach people valuable skills, the valuable skills are the things that that you can't buy off the shelf, right? And so if you want to put this thing together, you're going to have to learn the valuable skills because you won't be able to put it together otherwise. And so I think that, you know, it is good to learn about how Arduino works. You know, these are great pieces of knowledge, but I think if, you know, do that if you want to be an Arduino programmer, learn about Arduino. If you want to be maybe an IoT developer, perhaps learn about Arduino. If you want to be a roboticist, build a robot. And I guess that's actually kind of the I guess the thought process behind my 4-week challenge. You know, build 4 robots in 4 weeks, where and it was actually a big. So I've run it once, and I'm thinking about running it again. It was a pretty big challenge actually, and I had a few ideas that I wanted to try out. So I wanted to go, okay, we're going to do it all in simulation, and it made me a bit sad doing it all in simulation because I like playing with robots in the real world, but I wanted to make it accessible so that, you know, you didn't have to commit to thousands of dollars worth of robotics equipment, especially if you didn't know that you really wanted to be a roboticist. Maybe you're just like trying it out. You know, maybe this is something for me. I don't know. And so, look, if I do it in simulation, then at least, you know, it's much cheaper, and you can at least get a sense of what's going on. And then I wanted to use ROS because I guess I'm a big ROS fanboy. I just think that it's the right integration layer. Like, it solves a whole bunch of problems. So we're going to use ROS. And then I wanted to basically show a kind of way of, you know, one thing that I see people don't do very often when they start learning how to be a roboticist is they don't really think about mechanical design at all. Like, so they're either going deep into the Arduino electronics or they're making really simple things. But you can simulate, I mean, you can simulate stuff that can't be physically made, but you could simulate a robot that looks like something that you want to make. And then as through, so, and by simulate, you can use a CAD program is what I really mean. You could use a free CAD program to draw a picture of what this robot might look like that's trying to solve the problem that you care about. And through drawing that, you'll learn CAD skills. And now you'll also learn how to assemble something with ROS because it'll be new. No one else will ever have done it. You'll be able to, you know, like, you'll have to learn how to do all the bits. You know, and if you could do that 4 times, I thought, if you could do it 4 times, then that's pretty good evidence, if not to anybody else, but at least to yourself, that any setting where you're like, oh, a robot needs to solve this, if you've built 4 robots in the past, then you probably will have a good idea about how to put the standard bits of robotics together to make that happen. So yeah, so that was the kind of general idea behind the 4 robots in 4 weeks challenge. It went pretty well, but it was actually really hard. I I have to admit, you know, I think a lot of people had a lot of struggle with it. You know, we got through it in the end, but it was really quite tough.
How many people?
Uh,
How many people did you have on the program?
I think I had 8 people signed up for it, which is pretty cool.
Hmm.
And I've had one
And
person sign up after the cohort. Yeah,
after it.
yeah.
Hmm.
Just looking at the replays and stuff.
So, I mean, this is especially when you're talking about courses, there's a lot of things that you can do online or watching videos and yeah, reading through documentation. But this kind of course, I can just imagine, I mean, 8 people, it's 8 people, right? And then times 4 because it's 4 robots, right? And then you have, I can just imagine these 4 weeks must have been very interesting for you in terms of time management because you needed to have time and different kind of questions because people have different kind of speed and different kind of knowledge. And I don't know
Yeah.
if you do like a level test where you do know, okay, at least everyone has this kind of knowledge, so we can start because you would like to make it accessible to everyone. I can just imagine there are some people that already know ROS and already did some cut design, but then you have people that never touched anything of this, right? So
Yeah.
I would.
It was hard. Yeah, that was a big and probably the time commitment was, I think, the thing that was probably the most difficult with that. I think that a lot of people, um, you know, I still do think that I said you need to put in an hour a day every day for 30 days basically to be able to do this. Um, and I think people went, yeah, okay, cool, no worries. And then yeah, I'm not putting in an hour a day, no way. But no, you needed to put in the hour a day to have enough time to get through it all. Um, so I think that was a bit tricky. Um, and yeah, there was a very vastly different set of skills actually. I was surprised. So I had everything from fresh undergrads or master students to I even had a robotics PhD turn up. Like he was a professor already at a university and he wanted to do my course. And it was he was one of my best students, but I was so I was trying to cater to quite a broad range, and
Was it a
also
paid
trying to do
course?
it. Hmm? It was
Sorry,
paid,
was
yeah,
it a, yeah.
yeah, it's paid course. Yeah, I was trying to cater to quite a broad range. Um, I also had one other perspective on that, which was a little bit tricky because a lot of people are a bit shy, um, and a lot of people weren't really comfortable doing this, but I was trying to get them to, and that was to treat the internet like your reviewers. So, you know, um, in typical university courses or any high school course or whatever, as you're aware, like, um, you know, the internet, like the tutor marks your work, right? But what I really wanted these my students to do was to actually, and I was giving them tips on how to communicate on LinkedIn in particular, and also Twitter if they wanted to allow them to share their work with others, because there's something super powerful. And I saw this during my time with the Spider robot company, was that you know if you want to get someone's attention on the internet, you just talk about them. And the internet has this wonderful way of, if you talk about someone, they'll hear about it. Just, like if you at someone, oh, sorry, I just lost my headphones. If you at someone, they will respond. But even if you just talk about them generally, there's a good chance that they might hear what you had to say. Um, and so, but there's a really fascinating thing for people who are looking for robotics jobs, people starting out early in their career, recent master's students, or even people who just want to establish themselves as thought leaders. If you could take a robot that existed already, that was already established company, and make a simulation of that robot, and then put it out in the world, that company is gonna hear about it. The same thing happened at the Spider Robot company. There was another team made a robot that was similar, and we found out about it. It didn't matter that it was on the other side of the world and that we were in totally different industries, and that we were in industry versus academia. Like, we found out about it. We thought it was extremely interesting. Um, and ultimately, one of the people who did that project came to work with that company not too long afterwards. And so there's this incredible power of um, talking about someone on the internet in a positive way. Obviously, you got to talk positively. And so one thing I was encouraging my students to do, if they were in that part of their career where they were looking for, for the next job, was to identify companies that they would like to work for, and then to create simulations of the robot that company, made, and then talk about that on the internet. Talk about how they went to about creating that simulation. And the reason why I think it's a really great idea is because the worst case, that student's going to learn ROS and learn CAD because they have to, and learn about the use case, right? Because robots that are commercially viable typically have to have a job they do, and so they come with already. You don't have to worry about learning about, we're talking about like learning about Arduino and stuff. Like, you're just trying to solve the problem that this robot solves. But they also have a company that's looking probably to hire people. And so worst case, you just learn about how to make robots. But best case, you make a relationship with a robotics company that exists, and they have a chat with you. And and maybe if you're good enough, they give you a job. So I think that's a sort of a untapped potential that people don't realize. But the trick is, of course, you have to be comfortable publishing. And what I found with some of my students was that they were just uncomfortable publishing on the internet. They're like, oh, my employer might think, I'm looking at being a roboticist, or something like that. and it was quite tricky because you can be in a really tough spot when you're in those situations.
I
If
mean,
you're listening to this podcast and you're one of those people, I'd say, you know, like usually employers um, will respect. Like I think good employers will respect your curiosity and respect that you're upskilling yourself to new capabilities, and you know, and as long as you're polite and nice and kind on the internet, um, people are gonna. It's just net positive, right? So, a lot of people were unwilling, but I think that yeah, even if you're employed already, like your employers might just go, oh wait, I've got an employee who now knows about robotics. Maybe I can get them to do the next robotics problem that we have, right? Like anyway, that's a bit of a ramble. Sorry about that.
no, no,
Yeah.
I think this is very, very valuable because, as I said, a lot of people are on LinkedIn, not because they have a job, but they would like to have a job
Mm,
and looking for opportunities, and especially for countries where it's hard to get these kind of jobs, or where the majority of opportunities might not lay in your own country, but rather in other countries.
yeah.
And so what you just said is, yeah, because I mean, younger people or younger folks is asking me, can you guide me? Can you tell me what should I do? And I think you said something that is very valuable, and that is, I mean, doing this kind of work has a lot of benefits. One of the benefits, for sure, you can in you might catch an eye on somebody is able to see your work, and obviously the opportunity was putting out your work puts you in a position where you first are able to get feedback.
Mm,
So I mean, especially in engineers or that are very product focused, it's very hard to get feedback when you're only at your own circle, right? So
yeah.
and they say, okay, this is very valuable. I cannot show it to anyone because this is my unique selling point, and this is very unique. I mean, the majority of times the idea is worth absolutely nothing if you're not able
Mm,
to deploy it, if you're not able to
yeah.
solve a problem,
Yeah.
and if you're not able to bring it on the street. So having this outgoing approach, I think has more benefits. Yeah, you get feedback, and that can,
Hmm.
if you're listening to it, you can get better faster.
Yeah.
But as you said, there's the possibility that someone's seeing you, right? And or
Mm,
you can get in contact with people that are solving similar. Just the other day,
yeah.
I was in our lab and I was listening to our machine learning engineers or robotists, and they were saying, okay, so this is the path that the robot is doing at the moment. Let's have a look, because we're not the first one who just want to move smoothly. Let's see if we can get an algorithm that is solving the problem already, and then we can use it here, right? So
Mm,
if you have the guts to put yourself out there, there might be a possibility that some people have the missing puzzle pieces that
yeah.
are, yeah, very valuable for you. So, and coming
Yeah.
together. So I just started recently a Telegram channel for that. So for people
Oh,
coming
cool.
together and talking about problems that they're having, I'm working together with Rob Knight and Trent Shumay. They have this
Mm,
Dex hand. They just released the first pictures
yeah.
of the second version of it.
Mm,
Rob is on a conference in south of France at the moment and is presenting his Hope robot. So because he said humanoid robots should not be only within companies, as you said, locked up. You
yeah.
used that term earlier, rather than having it at open source and then people can contribute to it. And if you think about the learning curve, right, I think this is something that Meta just did. All the
Mm,
large language models they have. I mean, this is so you're putting it out there, but you have so many people working on so many different projects. The learning curve is just immense. So there is no
yeah.
company in the world that have that kind of working force, right? With so
Hmm.
many curious people. I mean, you can pay a lot of very intelligent people that can work together. But
Yeah.
yeah, I think this is very, very interesting.
Hmm. Yeah. And it's funny too, because like, I mean, everybody wants to make money, right? Of course. And people are like, oh, but if I give it away, I won't be able to make money. But like sometimes it's not the actual like it's not that tech that's the valuable bit. It's the when it solves someone's problem,
Hmm.
So yeah, it
Yeah, I
you
mean, I
know,
was I was curious the way you put it, because this is already someone who was in the industry. So because people from academia, they trying to solve a problem, but in the real world, you need to solve a problem that is worth paying for. So if you
Mm-hmm.
don't, if you just solve a problem that is very interesting from a research point of view, that might be interesting for you and your group, but in the
Yeah.
very end, as you said, someone needs to make money out of it. And if you would like to spend more time on that project, then you better find a way to. I mean, this is the wrong way doing it. Finding a way to monetize it, rather
Mm.
versus finding a problem that is so valuable for people that they would like to spend money on it so you can solve
Yeah.
it, right? Because
Yeah.
it reduces the pain they have, right?
Yeah. And that's why I think that yeah, like, studying successful robotics that are backed by companies that are successful is really interesting because yeah, because it you don't have to hope that there's a valuable problem, because if the company didn't solve a valuable problem, then it would be out of business. So, you know, usually anyway, I mean, obviously some companies are exceptions to that, but most of the time, you can expect it that
No,
company exists because it's
I think
valuable.
every single company depends on what kind of problem it is, right?
Mm.
I mean, sometimes the or you create a problem. You would like to
Yeah.
have this because it's so nice to have it, and
Mm.
but yeah, this goes a different path. No,
Yeah.
um, I'm very thankful that you took the time. I really would like to have a catch up on that, especially as you said you would like to have another round of that course. So the last time
Yeah.
was 4 robots in 4 weeks. I don't know if it needs to be more robot or more time,
I mean,
but
I actually think, you know,
or less robots and
I
more time.
I think it might be less robots. Because the bit of feedback I got is we rushed through. I mean, intentionally, I was trying to get people to do it really fast, but we rushed through some, I guess, of the like, because it's focused on software. We rushed through over the basic software tools and the ways that you set up a ROS project. Um, as well as I rushed through because I wanted to use a CAD tool. I use FreeCAD because it's free and I think it's pretty cool. But I think FreeCAD was a sticking point for a lot of people. So I'm tempted to, yeah, either make it longer or make it fewer robots. But I want to get people to the point where they can see a problem and then imagine a robot that could solve that problem and then could at least simulate that robot in Gazebo with Ross. So yeah, I don't know. We'll see. Still work. Actually, what I am looking at right now, I don't know. It's fun. I need to actually make another one, but what I want to do right now is, so the coffee robot that I started writing about LinkedIn about, that that coffee shop just went like crazy awesome for robotics, and they went and bought a UR5E arm hanging off a gantry above the coffee machine, and which is really super cool. And the owner of that shop is a really good friend of mine, and he went and he coded it all up himself. Actually, I didn't have the time to help him with the arm development, and he made it work. But what I think would be really cool, and it's not quite 4 robots in 4 weeks, but it is certainly very cool, is to look at a system where that coffee delivery robot that delivers robots inside of the coffee machine and that UR5E arm kind of work together to, say, move coffee onto the trolley machine, and then trolley trundles out with it. Um, and so in that vein, I managed to create a 3D scan of the Game City. The Game City is the name of the coffee shop, and loaded that with a little bit of work. It wasn't as straightforward as I'd like, but taking a little step with Blender, managed to get it as a file format that would load into Gazebo. And now I have, and then a little bit of rigmarole and configuring of ROS. I've now got a simulation which has both the robot arm and a gripper on top of that robot arm, plus my coffee robot, all simulated in the same environment, all running ROS. So it's really fun, and I want to try and. I think my current plan, hopefully it works, is my next version of 4 robots in 4 weeks will probably be something like maybe the first 2 robots will be those 2 robots in that world, and then the second 2 robots could be, or at least maybe the third robot, maybe it would just be 3 robots in 4 weeks, but and then a third robot, which is, the student has to find a robot that they want to make and then simulate an environment or capture. That was the cool thing, is that because modern phones can do photogrammetry, and so you can just capture an environment, and now you can have your robot in a sort of digital twin of that environment. So yeah, that's sort of what I'm looking forward to with this course. I
I
don't have
see
a
there's
start date yet. Sorry?
no, I see that this conversation is being accelerator of your thoughts. So so while you're speaking, I can see, okay, maybe I could do this, maybe I could do this. So this is a good way to like I said, you're putting it out there, and then some people
Mm,
respond to it, and then I think what is very interesting in you while putting it out there means articulating your ideas. And
yeah.
this helps in the thinking process. I always tell this to my customers. Uh, Write it down.
Mm,
I need it to be written down so I can present it to the engineers. So I can talk, we can
yeah.
talk it together with the engineers and the product people. Because if it's only in your head, it might be very, very clear. But if you put it on paper, then you see a lot of a lot of it is just gibberish, and a lot of it
Yeah.
is
Yeah.
unuseful.
Yeah.
And other people can actually respond to that, because responding to your thoughts, it's a bit tricky.
It's true. It's true.
Um, I think it's so interesting. The next time you do this course, give me a heads up. I
All
think
right. I'll let you know.
I might try it out myself.
All right. And if any of the viewers there, let me know if, what would you take? Is this, I don't know, love some feedback on the idea. Um, I'm most interested in people who are up for the challenge of posting, because I think I really truly believe that that's something no one is doing in education. No one is like getting people to publicly share the things that they learn. I reckon that'd be fun. So yeah.
And it's a
Anyone out there, let me
multiplier,
know. Yeah. Yeah.
because then people see, okay, I mean, this is like live testimonials, because it
Yeah.
shows what you actually do in the program. And if you incentivize people in, so this is part of the program actually, because you do need that kind of feedback to make it work, because you will not be able to solve everything on your own.
Yeah.
Not because I don't want you to, but because this is the way problem solving works. There will
Yeah.
never be the situation where you solely just in your little cabin without any resources, with any
Yeah.
yeah, the possibility to talk to others, solving any problems. So it
Yeah.
really and I think this comes back to this thing that you said about putting it out there, and then you might see a robot company, because what
Mm.
hiring is expensive, right? So
Yeah.
hiring someone and you don't know what they actually be capable of,
Yeah.
versus look, so I actually took the model and designed it myself and solved the problem. So this is the perfect advertisement for your skills for that company.
Yeah. Oh my God. Like honestly, yeah. As a hiring manager, I've hired people in the past. If someone basically did something super related to the project that I was literally on and said, I want to work with you, it'd be like, oh my God, well, yeah, I know it's de-risked. I know that you'll be immediately good, right? Because there's nothing worse as an employer, nothing worse than someone who sounds so sweet and then they can't do what they said they can, and then
Yeah.
you have a big problem. So yeah, and there's nothing better than someone who just gets going and you're like, oh my God, this is amazing. So yeah.
This is exactly the puzzle piece that I was looking for.
Mm.
Hmm.
Yeah, exactly. Exactly.
Um, John, the day starts here. The day ends on your side. I was
Yeah,
very fortunate
this is
to
great.
found you and to saw you, because you were putting yourself out there. I'm very happy that you admitted to this episode. So thanks for
Thank
taking
you
the
for having me
time
on.
and giving us insight in your story. Yeah, I will share it a few times this week. So I will see what I can find, what I can find about your work, and incorporate it in advertising this episode. Thanks
All right.
for staying with me, and I hope you had as much fun as I did. And yeah, looking
Yeah.
forward to have this 4 week, three robots 4 weeks challenge.
We'll see. End robots in 4 weeks. Yeah. Thank you. All right.
Bye
Cheers.
bye. Take care.